Hello guys, so welcome to IIT Gate classes. Here once again we will be starting our discussion on theories of failure. That is second part of the theories of failure, where we have to discuss the remaining theories of failure. That is a Higgs theory. We also call this to be a maximum or total strain energy theory, right? Maximum strain energy theory. We also call this to be a total strain energy theory. Try understanding. So this is basically the theories of failure, where the person hates. He did not focus attention on the yield strength, or maybe whatever the sigma one, and whatever the maximum shear stress. He just focused on the particular strain energy part of that. Strain energy of a particular member per unit volume he has considered. What he has said, under combined loading case, under combined loading case, whatever the strain energy is there per unit volume in a strained material, when it is reaching the limiting strain energy, that is a strain energy maximum possible allowable at the yield point per unit volume, if it is exceeding that particular, if it is just exceeding that yield, whatever the strain energy at the yield point, then we say that failure will happen. That means, wait on. What I'm saying, statement, if total strain energy per unit volume, if it is more than strain energy per unit volume at the yield point, at yield point in a simple tension, then we say that the failure will happen. Then failure will happen. Then the failure will happen. Now, what is the strain energy? Let's calculate. So, strain energy, I will be talking a little bit about the strain energy. Energy stored per unit volume, you know, strain energy. Whenever you are applying any kind of load to the body, you are deforming that body. So you are doing some kind of work. That work will be stored in the material. That work will be stored in the material in the form of what? Strain energy. That means suppose there is a body which is being subjected to different kinds of load, like P1, P2, some kind of twisting movement, some kind of bending movement. Different types of load has been applied. But at a particular point, if I just zoom it out, and if I say this material is being subjected to something like this, sigma 1, sigma 2, and sigma 3, then what is our strain energy per unit volume? Already we know something about this strain energy. Strain energy is what? Area under what? Whatever the yield point is there, area under this particular curve will be what? My strain energy will be there per unit volume. And what is the area? Half of sigma into what? Strain. This is basically the strain energy per unit volume, right? This is nothing but the strain energy per unit volume, my different, right? Whatever the energy stored till the yield point, we call this to be a strain energy per unit volume. Obviously, very similar under see, this is for uniaxial tension test, right? But for a complex loading case, the total strain energy I will be representing by U. U is what? Strain energy per unit volume, right? Half of sigma 1 into epsilon 1, half of sigma 2 into epsilon 2, half of sigma 3 into epsilon 3. Right, my different. So this total strain energy, remember that it is a part of the volumetric strain energy. It is containing some part of volumetric strain energy, and some part it is containing about distortion energy. Right? Now, so the total strain energy can be written as, if you just convert epsilon 1, that is sigma 1 divided by E, minus mu into sigma 2 plus sigma 3 divided by E. Similarly, what is the epsilon 2? Sigma 2 by E minus mu by E, sigma 1 plus sigma 3. Epsilon 3, if you just write sigma 3 by E minus mu by E, sigma 2 plus sigma 1. So if you just write into the formula, you will be getting direct this formula 1 upon T 2E, sigma square plus sigma 2 square plus sigma 3 square minus 2 mu, sigma 1, sigma 2, sigma 2, sigma 3, sigma 3, sigma 1. This is the combined formula. This will be the combined formula, my different, right? And everybody know that what is the sigma 1? Sigma x plus sigma y by 2 plus under root of sigma x minus sigma y by 2 whole square plus tau xy whole square, right? So finally, if I want to calculate at the yield point, if I want to, this is the total strain energy per unit volume, under complex state of stress conditions. But I want to calculate what is the strain energy at the yield point. At the yield point, my dear friend, sigma 2 will be 0, sigma 3 will be 0, and sigma 1 will be what? Sigma yt. In a simple tension test, under uniaxial loading condition, in a UTM machine, we will be getting sigma 1 as sigma yt, sigma 2 will be 0, sigma 3 will be 0, and accordingly, what I will be getting, my dear friend. At the yield point under uniaxial tension test, what you will be getting? Total strain energy at the yield point, sigma yt square divided by 2e. If you just put into this formula, my difference, sigma 2 0, sigma 3 0, sigma 2 0, sigma 3 0, sigma 2 0, sigma 3 0, all the terms will be gonna be 0. Sigma 1 is what? Sigma yt. You will be getting sigma, that is the strain energy at the yield point. That as simple as that, right? If total, whatever you have calculated, 1 upon 2e, sigma square, sigma 2 square plus sigma 3 square minus 2 mu, sigma 1, sigma 2, sigma 2, sigma 3, sigma 3, sigma 1. If this particular value, if it is less than or equal to sigma yt square divided by 2e, we say material is safe. We say the material is what? Safe, my dear friend. So sigma square plus sigma 2 square plus sigma 3 square minus 2 mu, sigma 1, sigma 2, sigma 2, sigma 3, sigma 3, sigma 1 should be equal to what? Sigma yt divided by factor of 50 whole square. So finally, we are calling this to be equivalent stress. We are calling this to be equivalent of permissible stress, right? So what will be the equivalent stress? Under root of sigma square plus sigma 2 square plus sigma 3 square minus 2 mu, sigma 1, sigma 2, sigma 2, sigma 3, sigma 3, sigma 1. This will be formula according to maximum strain energy theory, right? This is nothing but sometimes called as Higgs equivalent stress. Higgs equivalent stress, my dear friend, right? Make a note point of this. Make a note point of this. Very, very important. Equivalent stress is nothing but what? Sigma yt divided by factor of safety. Now, when you see the plot, that is a failure curve. That is nothing but the safety region. What you will be observing? Why this curve is an elastic curve? Because when you just focus your attention, just focus. What you will be finding? What you will be finding? Sigma 1 square. Sigma 3 is 0 for biaxial state of stress condition. For biaxial state of stress condition, sigma 3 0, sigma 2 square minus 2 mu, sigma 1, sigma 2 minus 2 mu, sigma 1, sigma 2 should be equal to what? SYT whole square. And what is this? Equation of ellipse. What is the equation of ellipse? Equation of what? Ellipse. Equation of what? Ellipse, right? so that you will be getting this particular formula. This will be the region. In this plot, I'm just plotting the superimposing the condition of maximum shear stress theory. This was the plot, something like this. Now, let's solve the same numerical what we have taken in the previous segment also. A body is subjected to what? Sigma 140, sigma 2 is 0, sigma 3 is what? Minus 70. The third principal stress they have clearly mentioned being 0, right? That's why I'm taking 0 also. They are mentioning, and according to 5 theories of failure, we need to find the maximum, what we call factor of safety we need to calculate, but we have to calculate very first of all by maximum strain energy theory. So accordingly, what we have to do, just put the formulas. What is the formula we have? Sigma equivalent, that is sigma yt divided by factor of safety whole square, that is what? Sigma 1 square plus sigma 2 square plus sigma 3 square minus 2 mu sigma 1 sigma 2 sigma 2 sigma 3 sigma 3 sigma 1. Sigma yt is what? 200 divided by factor of safety. Sigma 1 is what? 40 square, 0 minus 70 square, 2 into 0.3. Sigma 1 sigma 2, 0 something 0. Sigma 3 is what? Minus 70 into 40. So if you just calculate, you will be getting approximately 2.21. And according to Tresca's theory, what was the factor of safety? You might have calculated 1.818. According to Tresca's, you got the answer as 1.818. That is 200 divided by 110 or 100 divided by, let me check, 100 divided by 55. So 1.818, we got the factor of safety, right? So what you are observing, my dear friend, as you can see from this safety region also, the big region, which is allowing the big regions. This is nothing but this dotted line is what? This black color line I'm just showing with the, this black color I'm showing with the what? Tresca's theory. This one. So what you're observing, which is having a larger area, the larger area has been given by what? This one. Which one? Higgs theory. The larger area has been given by what? Higgs theory. The smaller area has been given by what? Tresca's theory. Automatically, which is going to give the more factor of safety? Higgs theory only, or maximum strain energy theory, or total strain energy theory. See, if you just consider one point here, after loading condition, you got the point P here. So according to Tresca's, it is automatically failed. But according to Higgs, still it is not failed. So what you're observing, my dear friend, if I ask you at this point of time, which is the safest theory, which is more conservative theory, is Tresca's theory or Higgs theory, what you will say? Among Higgs theory, that is the maximum strain energy theory, or Tresca's theory, among these two theories, if I'll just asking you, which is giving me the safest theory? The answer must be what? The theories which is giving you the least factor of safety, the theories which is giving you the least factor of safety will be the most conservative theory, the most safest theory. The factor of safety given by the Higgs theory is what? 2.21. He is saying that, what he is saying, this particular Higgs theory, what he said that, okay, you can take any diameter because you have the large factor of safety, you know, the chances of failure is less. But Trescas, what it is saying, it is suggesting you that you better take precaution. You better take precaution before only, because you have the least factor of safety. You cannot allow so much of load. You better take more diameter. He's just allowing you more. But what about the Higgs theory or maximum strain energy theory? He's saying that you have a lot many amount of factor of safety. Why you're bothering so much? Take less diameter, apply more amount of load, and you fail the material. But Trescas, no. He is just giving you the better results as compared to the Higgs theory. So among all, the conservative theory will be Trescas only. Among all the theories of failure, if I'll be asking you, the Trescas will be the most conservative theory. He will be giving you the least, he will be giving the least factor of safety among all the theories of failure. The most worst condition will be what? For maximum normal stress theory only. As we might have calculated, what is the factor of safety we have calculated according to Rankine's for same problem, 2.86. He is just giving you the bluff idea that you take very less diameter so that you can work also, because you have so much amount of factor of safety. What is the meaning of factor of safety? How far you are from the safety regions, how far you are from the safety region. And what you will be observing that, what you will be surprisingly observing that the region of safety for Rankine's theory will be so large. This much of large value is there, right? The green color which I am showing you, that is a Rankine's theory. That is the worst theory. That is a completely worst theory, right? He is giving you the false idea, false hope that you have so much of factor safety, even you are taking a very less diameter, you will be survived. But that is not the case, right? So in this manner, we have to learn the subject rather than just solving the numericals. Solving the numerical is a part of the gate preparation. I'm not denying from the fact, but you must be understanding what is the if any point of time this particular gate examination we have the MSQ game completely. So we must not rely on the completely on the numerical solving ability. We must understand little bit of theoretical aspect of the subjects also, right? Let's focus on our the last theories of failure, that is distortion energy theories of failure. We also call von Mises theory, very much suitable for brittle material, very much suitable for ductile material. Sorry, I said brittle material. No, very much suitable for ductile material. Even if I'll be asking you amongst Tresca's theory and von Mises theory, you better select von Mises theory, because he is not giving you the false idea, false hope, just like our Rankine's theory, but he will be giving you the reasonable region where you can choose and select the diameters. What is this? Sir, what we have considered here? Total strain energy we have considered in our previous segment. Now you no need to bother about total strain energy. You should only bother about the distortion energy. What is the total strain energy? Volumetric strain energy plus distortion. But for your design calculation, my different, what you have to consider, you have to consider for this case only you have to consider distortion energy. Only you have to consider the strain energy which is responsible for shape changes, right? Which is responsible for shape changes, right? Let me give you some idea about this. Now, what is the volumetric strain? Which are responsible for volumetric changes? Average stress into what? Volumetric strain. Half of sigma 1 plus sigma 2 plus sigma 3 divided by 3 whole square. Volumetric strain you will be studying in the basic chapter of the what? Axial loading case. 1 minus 2 mu divided by E. Sigma 1 plus sigma 2 plus sigma 3. 1 minus 2 mu divided by E sigma 1 plus sigma 2 plus sigma 3. So if you just write the formula of distortion energy, we can write total strain energy minus volumetric strain energy. You can do as a homework. I will be writing directly the distortion energy formulas. I will be writing directly the distortion energy formulas, something like this. 1 plus mu divided by 6e, sigma 1 minus sigma 2 whole square, sigma 2 minus sigma 3 whole square, sigma 3 minus sigma 1 whole square. This will be the values, right, my dear friend? And if you just want to calculate what is the distortion energy at the yield point, at the yield point, 1 plus mu divided by 6e. See, at the yield point, sigma 1 will be what? Sigma yt, sigma 2 is 0, sigma 3 is 0. So you're going to put, and you will be getting the answer as something like this. Sigma 1, sigma 2 is 0, sigma 2 is 0, sigma 3 is 0. So we'll be getting 2 times, right? Something. Just wait. Here you will be getting answer as sigma 1 square plus sigma 1 square, that is 2 sigma 1 square, that is 2 into sigma yt square. So this will be cancelled out. So 1 plus mu divided by 3e into sigma yt square. We can also write 1 plus mu e divided by 3e, sigma yt divided by factor of 50 whole square. Right? So what this theory has been said, if you recall this statement, the failure will happen. Read this statement. The failure or yielding occurs at a point in a member when the distortion energy, when the distortion strain energy, also called shear strain energy per unit volume in a stressed material, reaches the limiting distortion energy. That is a distortion energy at yield point. We say the failure will happen. That means the total distortion energy, if it is just less than or equal to distortion energy at the yield point, we say that material is safe. It is more. If it is more, we say material is failed. So what is the total distortion energy, my dear friend? What is the total distortion energy? 1 plus mu divided by 6e, sigma 1 minus sigma 2 whole square. See, we have to remember the formulas. There is no, we cannot escape from that. Sigma 1 minus sigma 2 whole square plus sigma 2 minus sigma 3 whole square plus sigma 3 minus sigma 1 whole square. That should be less than or equal to 1 plus mu divided by 3e, sigma yt divided by factors of t, that is a whole square. So what is a basically sigma yt divided by factor of 50, my dear friend? You will be getting answer as 1 by 2 sigma 1 minus sigma 2 whole square, sigma 2 minus sigma 3 whole square, sigma 3 minus sigma 1 whole square. And this is nothing but equivalent stress. Half of sigma 1 minus sigma 2 whole square, sigma 2 minus sigma 3 whole square. This is called as von Mises equivalent stress. This is called as von Mises equivalent stress, right? So these are the region of safety for this one, right? The region of safety. So it's a very similar kind of things only, but here we have a pure ellipse having a major axis, semi-major axis as A, and semi-minor axis to be as B, right? So my dear friend, if I'll be asking you at this point of time, what is the relationship between SYT and SYS or tau S for this von Mises theory, then what you will say? What is the relationship? It's a very easy to derive the relationship. My dear friend, What is the value of equivalent stress? Equivalent stress, we know the formula. The formula which I have written. Note down the one more formula. Half of sigma x minus sigma y whole square, sigma y minus sigma z whole square, sigma z minus sigma x whole square, plus 6 by 2 tau xy whole square, tau yz whole square plus tau zx whole square. Basically, I just want to derive the relationship at the yield point. At the yield point. So what I will be just taking the value. I will be taking the values for 2D stress. For 2D, what I can write? Sigma z will be 0. So I'll be writing the formula as sigma x square, sigma y square minus sigma x, sigma y plus 3 tau x y square. Sigma yt divided by 1, this one. Sigma x is there. Sigma x is what? Sigma yt, right? So what we can write? Okay, directly you can remember the formula. Directly you can remember the formula. Whenever we are applying the twisting, whenever we are applying the twisting, for twisting, whenever you apply the twisting like this, whenever you just apply the twisting, what you will be observing? You will be observing one thing, that sigma 1 is what? Sys. Sigma 2 is what? Minus Sys. Put this value, put these values into this particular formula. Which formula? This particular formula. What you will be observing? You will be observing something. Sigma 1 square plus sigma 2 square minus sigma 1 sigma 2, because sigma 3 is 0. So sigma yt, what you will be getting? Under root 3 into what? Sys. So Sys will be what? 1 upon root 3 into Syt. 0.577 times of Syt. This is our formula regarding what? Von Mises theory. What is the relationship between Sys and Syt for Tresca's theory? For Tresca's theory, it's a very simple. Sys will be what? Syt divided by 2. Getting my point? So very, very important thing. Now we will be solving the same numerical that we have discussed. The same numerical by using this what? By using the maximum distortion energy theory, von Mises theory. Understand what I'm talking about? Just understand very carefully. So here once again we are taking into the account of this one. What is the formula we have? Sigma equivalent, or we are calling sigma yt divided by factor of 50. That is equal to what? Half of sigma square. Sorry. Sigma 1 minus sigma 2 whole square. That is what we have the formula, right? Sigma 1 minus sigma 2 whole square plus sigma 2 minus sigma 3 whole square plus sigma 3 minus sigma 1 whole square. This is what we have written. Just check it out. This one. The same formula I'm using once again here. So instead of putting this, what we can put? Sigma yt. Sigma yt is what? 200 divided by factor of 50. Half of sigma 1 is what? 40. Sigma 2 is what? 0. Sigma 3 is what? Minus 70. So 40 whole square plus sigma 2 0 plus 70 whole square plus minus 70 minus 40 whole square. So 200 divided by factor of 50. What you will be getting, my different? 40 square plus 70 square plus 110 square. 9300 you will be getting. Then factor of safety would be what? 2.07. So still, if I'll be asking you among the maximum distortion energy theory, or we say von Mises theory and the Tresca's theory, which is giving you the most conservative results, once again the answer will be Tresca's only, because it is giving you the large factor of safety, least factor of safety as compared to this one, right? So it is alarming you more as compared to this theory. But still, for ductile material, we say this is a very much suitable. We say this is a very much suitable theories of failure, right? So these are the aspect of what we have discussed regarding this complete theories of failure. The next chapter would be that we are completing is torsional, right? Torsional loading case. Thank you all.